in this section, was pretty much what you already did in the last lesson and applying it to word problems. But before we can dive into that, we need to talk about some vocab words. And the first vocab word we're going to talk about is angle of elevation. The angle of elevation is just the angle between the line of sight and the horizontal when you're looking up. So we look at this example in the diagram. Here's the horizontal, here's the line of sight, and it's the angle, because the guy is looking upward, it would be an angle of elevation. How I like to think of it is if you're going from the horizontal, so that flat line to the slanted line, if you draw an arrow, and it's pointing up, then it's an angle of elevation. That's how I like to go to the top. The angle of depression is the angle between the line of sight and the horizontal when you're looking down. So if we take a look at the diagram, here's our horizontal line, here's our slanted line of sight, because the owl is looking down at that poor little squirrel, and is a angle of depression. Again, you can use that test when going from a horizontal to the slanted line of sight. Draw an arrow. If that arrow is pointing down, then it is an angle of depression. One thing to know is that the angle of elevation is always congruent to the angle of depression. The reason is because the angle of elevation and the angle of depression are always alternate interior angles. What we talked about last unit, and we'll see this in an example here next. Again, angle of elevation is when you're looking up. So if you're going from the horizontal to the slanted, your arrow will be pointing up. Angle of depression is when you're looking down. And draw that arrow from the horizontal to the slanted. If the arrow is pointing down, then it's an angle of depression. So, in example 1, we're going to use the diagram below to answer the following. For A and B, for A we need to name the angles of elevation, and for B we need to name the angles of depression. I'm going to do this at the same time. It'll be more helpful. If we look here, all these horizontal lines, right, and all these slanted ones are our lines of sight. I'm going to go through each angle, do the arrow test to see whether or not they're an angle of depression or angle of elevation. So to do the angle test, you always start at the horizontal. I'm going to start right here and make an arrow connecting with that slanted. My arrow is pointing up, so that means it's an angle of elevation. Go to the next one. Here's our next horizontal. It doesn't matter which direction you go. I'll test angle 4 first. Going from my horizontal to my slanted. Well, that arrow is pointing down, so it's an angle of depression. We're going to test angle 1 now. Again, start at the horizontal. Point up. Pointing up. So it's an angle of elevation. And then the last one, we'll test angle 3. Horizontal to the slanted. My arrow is pointing down. So it is an angle of depression. And then for C, it's saying list all the pairs of congruent angles. Well, we said in that last little section that the angle of elevation is always congruent to the angle of depression. Because if you look, all these horizontal lines, so this horizontal line and that horizontal line, they're parallel to each other. This green line right here, connecting angle 2 and 4 is your transversal. So think angle 2 and 4 are alternate interior angles, because they're inside and opposite, which makes them congruent. So angle 2 is congruent to angle 4. Same thing with this horizontal and this horizontal. They're also parallel to each other. So angle 1 and angle 3 are congruent. Again, because they're alternate interior angles. They're inside and opposite. Now that we kind of talked about this vocab, we can go ahead and apply this to some word problems. So we're going to do example 2 together. If you look at example 2, it says a lighthouse in Cape Hatteras, North Carolina is 200 feet above sea level. If it spots a boat that is at an angle of depression of 28 degrees as shown, what is the horizontal distance to the base of the tower? Down to the nearest foot. Well, I'm first going to label everything they gave us. So they said the lighthouse is 200 feet above sea level. I'm going to label that 200. It already drew in the angle of depression for us, this guy right here. Here's our angle of depression. They said it's 28 degrees, and we know it's the angle of depression because when we do that arrow test, we go from horizontal to slanted. That arrow is pointing down. Okay. And then we're trying to find this piece right here, the distance from the bottom of the lighthouse, the base, to the boat. Well, that's what we're trying to find, so I'm going to label that with X. And if we're trying to figure out how to solve this, look at this shape right here. We have a triangle. Not only is it just a triangle, it's a right triangle. So whenever we're trying to find the missing side of the right triangle, we can use SOHCAHTOA. We can use trig. Exactly like what we did in that last section. So I'm going to go ahead and write SOHCAHTOA. So, that's the second part. SOHCAHTOA. The only problem is you don't have an angle on the inside of our triangle because we never use the 90-degree angle when we do SOHCAHTOA. But we just said that angle of depression is congruent to the angle of elevation. So this angle right here is 28. That means that angle right there is also 28. So now our angle's on the inside of our triangle, and we can use SOHCAHTOA. Circle your angle. Across we label as our opposite. Across the line 90 is our hypotenuse. And the guy left over is our adjacent, just like what we did in the last section. Okay. Look at which side's giving you pieces of information. We look here. We have X. Here we have 200. And those two pieces are our opposite and our adjacent. So O and A. You look at SOHCAHTOA. Which one has our O and our A? That would be tangent. And finally get to use tangent. We didn't really see tangent much in the last section. Oh, use tangent. You're going to write tan to abbreviate for tangent. Write your angle. And then the ratio. Opposite, which is 200, over adjacent. Remember to solve this when X is down low, that helpful little saying, you switch a row. So the X and the tangent are going to trade places. And then I'm going to show you my graphing calculator, how you would plug this in. If you don't have a graphing calculator and you need help, just make sure you ask your teacher. They'll be happy to show you where it's at on your calculator. But to plug this in, all you're going to do is just write 200, then the division sign. Remember your sine, cosine, and tangent are right here on your calculator. They're always going to be right there if you have a graph. So that's how you'll plug it in your calculator, and you hit enter. So this is saying that X is about 376.1. but make sure you read the directions. It says round to the nearest foot. So we were to round that to the nearest foot. We get about 376. Okay, make sure you label your answers with the proper units. Go ahead if you need to rewatch the video. If not, you can get started on the practice.